Now it's recording. So example 1, use set notation to write the members of the following set. Question A, odd numbers between 1 and 10. So what is an odd number? Odd numbers are those numbers which cannot divide by 2. Cannot divide by 2. For example, 1, 3, 5, 7, 9, ... Okay, those are odd numbers. So we want the collection of odd numbers between 1 and 10. So we use a pair of braces to denote we are building a set. The first item or first member of the set is, look, it's obvious, it's just 1. The second member of this set is just 3. And we can continue to write 5, 7, 9. However, we cannot write 11 because 11 is not between 1 and 10. So it does not satisfy the requirement of odd numbers between 1 and 10. So after we check it, we found that we complete all the members. So we just completed the braces. This is my braces, okay? Braces. So this is our first set. Braces 1, 3, 5, 7, 9. And we use a comma between those objects so that they can be separated and will not be misread by others. Okay, any question on this first one? Okay, let's just continue. Question B, odd numbers between 1 and 100. So here we have a list of odd numbers. The next one should be 11. And the next one should be 13, 15, 17, 19, blah, 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 blah. Too many of them. We have too many odd numbers here. So what should we do with so many numbers between 1 and 100? I mean, we are lazy. We don't want to write every number until the number 99. Okay, we are very, very lazy. So instead, we remember that we can use 3 dots to indicate a continuing pattern if there are too many members of to list. So let's just write as we did for question A. 1, 3, 5, 7, 9, blah, blah, blah. Too many. Okay. We omit all the items between 1, 9, and 99. That's it. So we omit all the members between 9 and 99 so that we can write them in a small space. Okay. Any question? Okay, that's still something easy. That means we are still in the high school or even elementary school. Next question is more about geography. The states share a border with Colorado. Wow. First of all, I'm not a native of Colorado. So how do I know what other states share a border with Colorado? The easy way to do that, Google Map. So let's open Google Map to see what are the states. I'm sharing my screen. Do you guys see my screen? Great.
Yes.
Yep.
Thank you. So this is Denver. It automatically turns out to be Denver. Let's zoom out. Okay, now you see we're on the Front Range area. Okay, now you see the whole state of Colorado. Let's see. Kansas, Nebraska, Wyoming, Utah, New Mexico, and Oklahoma. Great. So those are all the states which share border with Colorado. So once we find the answers in Google Maps, let's just switch back to our lecture notes. So let's write. Okay, so Kansas. So if I misspell any name of the state, please correct me. Or if I forgot any state, please also correct me. I think the next one is Wyoming. Let's just write their name in short, okay? Just make things easier. Wyoming, in short, WY. Utah. Nebraska. What is the letters in short for Nebraska?
I think just NB.
NB?
Yes, I think so.
NB, thank you. Nebraska. Oklahoma, OK State. New Mexico, NM. Is that all? Did I miss anything?
Arizona.
Actually, Nebraska is NE.
Oh, thank you. Thank you, Nebraska NE. Thank you. Did I miss anything or misspell anything? Okay, so someone give us a very good question. Are we adjacent to Arizona? That's a more of a philosophical question. So are we really adjacent to it? So in my mind, we are not adjacent to Arizona. I know some of you may have been to the Four States Corner, right? Four Corners State. How do you pronounce this point? Yeah, how to pronounce this point on the borderline with four states? Do anybody know what's the name of this place?
It's called the
Four
Four
Corners
Corners.
Monument. Okay, so here's the thing. So in my mind, we are not adjacent to Arizona because our borderline only touch at one point. So we do not share borderline, we just share border point. So that's my philosophy. If you disagree with me, that's completely fine. Okay, so if you write Arizona is also adjacent to Colorado, I will give you full credits. Okay, so if you do not write Arizona, that's also fine for me. You also receive full credits. That's it for the dispute with Arizona. Okay, let's just complete this process. You see? Okay, those are all states. Here is a little bit controversial issue about politics. So I actually don't know the answer for this one. Houses of the US Congress. So I know we have some people who is working in the government. Okay, so can anyone help me on this question? What are the houses? I mean, in my mind, as a foreigner, the first house I'm thinking about right now is White House. Yeah, the first house is White House. The second house is what house? Yeah, I'm just joking. I know White House is not a part of the Congress. Okay, this is just joking. Okay, not a White House. Okay, so anyone can help me on this one? What are the houses of the US Congress?
House of Representatives.
And the Senate.
Okay, great. House of Representatives and Senate. All right. Did I misspell any word? Okay, great. So first of all, let me emphasize this again. Do not copy my White House. White House is not a part of the Congress. I was just joking. Okay, the final set notation should be a brass and the element, House of Representatives and the Senate. Then use another brass to complete. Okay. Any question about ABCD?
Nope.
Okay, Savin school. Let's continue. Okay, so once we finish those examples, it's important. Those examples are just helping us to understand the definitions. Recall what is the definition? Set, just a collection of objects. Okay, then you have the members inside the sets. Those are most key ideas, most important key ideas. So let's continue to practice 2. In practice 2, the set is given. You have to describe what are they. You have to describe it. So the first set is given as January, June, July. So does anyone know what this set is about?
Months.
It's the months of the year that start with J.
Very good. All the months is start with, when I write W slash, it means with, okay? Initial J quote. Okay, so how about the next one? 1, 2, 3, 4, 5, comma, ... Okay, this one, I just tell you, this is all positive natural numbers. So here's a little bit controversial history of mathematics. So when I were in the elementary school, we consider 1, 3, 2, 3, 4, 5 to 100 to 2000 to a meaning and ... They are all natural numbers. At that time, we didn't consider 0 as a natural number. However, when I grew up, I think the mathematics has been changed. Now 0 are also considered as natural number in the general math community. So that's why I emphasize this is all positive natural numbers. Okay, so 0 is not included. So if 0 is included, we can just say these are all natural numbers. Okay, any question on this one? Okay, so how about example 3, C.
Multiples of 10.
I'm sorry, can you repeat?
Multiples of 10.
Very good. But I think something is missing. Rochelle? Yeah. Do you see something is missing in your description about this set?
Multiples of 10 From 0 to 100.
Very good. You get it. So all multiples of 10, multiples of 10 between 0 and 100. So this is included also. Okay, this is included. It's between 0 and 100. That's it. Any question? Let's continue. So the last one is a little bit about biology. Crown, roots, trunk, stem, bark. Do we have any kind of biology measure here? Oh, I remember, this is a math for liberal arts. So we don't have any biology measure here. But I'm pretty sure all of you have took some kind of high school math, right? A high school biology. So what is this setup is about?
Parts of a
Parts of the
tree.
tree.
Of a tree.
Very good. Parts of a tree. That's it. We're done with the first page of the lecture notes. Okay, so after we finish with all the wording problems, now here comes a little bit of artistic painting problems in our lecture notes. We're going to learn Venn diagrams, Venn diagrams. So again, those are definitions. A Venn diagram is just a diagram. Use circles to represent sets. The Venn diagram gives a simple visual way to describe relationships among sets. If A is a subset of B, then all members of A is also members of B. So right now you may not know what is a subset. So let's turn to this graph help. It means if A is a subset of B, so any elements of A is also elements of B. That is just definition of so-called subset. Okay, just A is also a part of B, but B may not be a part of A. So here's a more concrete example. So my document camera do not see those letters very clearly. So I just tell you, this is non-mammals. These mammals that are not whales. So you see a big circle to represent mammals. Okay, this is mammal. And you see also a small circle represent whales. So let me ask you this question. Are whales mammals?
Yeah.
We need to find some pictures of mammals. Okay, so in order to persuade you that whales are real mammals, let me first show you what I found on internet. So by definition, mammals are those animals which drink milk, right? Which can produce milk so that their offsprings can drink their milk. Is that true? Just like when we were young, we drink milk from our mothers. So when I search whales and milk, I obviously found that how do whales breastfeed underwater? BBC Wildlife. So let's click on it to see how they drink milk. So this is a scientific report, I mean, for public purpose. But after gleaming through those pictures, you definitely know that whales do have nipples and whales do drink milk. Okay, so we are sure that whales are indeed mammals. Okay, so I will leave that checkup to you. Okay, so let's come back to the question. So we checked that whales are indeed mammals. However, are all the mammals whales? So mammals here is a set. It consists of many other animals, right? It consists of you and I. So mammals, you and I, we are also mammals, right? But we definitely not whales. We are humans. So let's check out this graph. So that's why whales belong to mammals. However, mammals have a larger circle because it also contains other species such as humans, monkeys, pigs, cats, dogs, horses, blah, blah, blah. So in this case, we can say that whales is a subset of mammals. However, notice that the mammal is only a circle here. We have a bigger rectangle. This bigger rectangle denotes all the animals. Okay, so can anyone give me an example which is an animal but not a mammal? Animal but not mammal.
Snake.
Fish.
I'm sorry, who said it?
Jellyfish.
Fish?
Reptiles,
Okay,
Mammals are anything that give live birth, and anything other than that are animals that lay eggs.
okay, great. So very clear description. Yeah. So right now we're sure that whales is a subset of mammals, and mammal is also a subset of animals. Animal has more other species other than mammals. Mammals have many other species other than the whales. Okay. So I'm just trying to explain this subset relationship. So let's continue. We just learned the first relationship between sets, that is a subset. A can be a subset of B. Right now, we're learning the second relationship of subset. Disjoint. If A is disjoint from B, it means two sets have no members in common. So if we draw a graph, we just draw a circle and another circle. Those two circles do not have any intersection. So let's see, in our case, what do we have? In our lecture notes, we have a circle of fish and another circle of mammals. I know, some people think that the whales is both a fish and a mammal. However, that's scientifically not true. Okay, whales are mammals. They're not fish. Okay, I know they look like fish, look like huge fish, but they are not fish. So we should be rigorous about science. The science here is fish, mammals, they are completely different. They do not have any intersection. Okay. Any counter opinion? Okay. Glad we don't have much science debate here. Okay, the third relationship we are talking about is sets are overlapping. So sometimes set A and set B, they have overlapping, which means they share some of the same members. Okay. So if we draw a diagram, we draw a circle and we also draw another circle, but those two circles have intersection between them. Here's an example. So here, the first circle is doctors. Second circle is women. So obviously, we have male doctors. We also have female doctors. Obviously, we have women who are working as doctors, and we also have women who is working in other occupations. We have women professors, we have women soldiers, we have women salesperson, we have women, all kinds of jobs, vice presidents, like that. So those two sets, they have overlap. There's some women doctors, but they are very different. Doctors, women, they are different sets, okay? So in this case, they have such a overlapping relationship. Any question on this example? Okay, it seems that today's class is going to be very fast. Okay, so let's look at the practice 3. So we need to draw Venn diagrams with two circles showing the relationship between the following pairs of sets. We have two sets, artists and painters. So artists, this is a broader concept. I know some painters are great artists, but I also know musicians are also artists, right? Actors, actresses are also artists. They're in performing arts. So artists have more than painters, right? But painters are definitely artists. So in this case, I would just draw a big rectangle. This means all people, okay? This means all people. And only a subset, only a small proportion of people are artists. So we draw a circle. And only an even smaller proportion of the artists are painters. I just use P because I don't have enough space to write out the whole word painters. I just write A to denote artists. Okay, let me be clear. A means artists. P means painters. Okay, so I do not want to just talk about myself all over the class. Since we're drawing interesting pictures, I think I can give you 3 minutes to draw the B and C, okay? I just give you 3 minutes to draw B and C. It's okay to make a mistake, okay? We're just practicing. Do it on your own. Okay, did anyone finish the drawing?
Yeah,
Okay, great. So let's draw snakes, rattlesnake. What is that? Obviously, rattlesnake is a subset of snake, right? So first we draw a bigger circle, then we draw a small circle. We use R to denote rattlesnake. We use S to denote the bigger circle. Okay, I think this one is easy. There's no controversial here, right? Again, politics. Politics can be very controversial. Rejected Democrats, reject Republicans. Okay, so here's the controversial part. I know Democratic Party and Republican Party, they're different parties. So here's the issue, do they have overlap?
yes.
I want to
and
listen to your opinion. Do they have overlap?
Yeah, they do, since they're both parties and they could agree on the same thing. So doesn't mean they're fully Democrat or fully Republican.
Okay. Okay, any different opinion? Thank you, Dasha, for sharing. Okay, if nobody voices any different opinion, we just assume that you have overlap, okay? We just take it for granted. So some people, oh, I remember, Donald Trump was once a Democratic. Then he turned out to be a Republican, right? Okay, so let's draw a funny picture with Donald Trump on it. I know he switched, but let's just make fun of him so that he becomes overlapping elements. So this is Democratic. This is a Republican. This is Donald Trump. Let's just use T. Okay, so nobody is offended by the way, right? Okay, so success. We finished drawing. Okay, so let's turn to the by diagrams with members. So once we have those photos, those paintings, those pictures, we are adding numbers to give more information about the underlying meaning of those graphs. So we can add information such as number of members. Okay, number of members underline this part. So first of all, let's look at this number. This number means all the number of elements, which is both in A and is also in B. If you have a number here, it means those elements who is in B, but not in A, not in this overlapping part. Okay, just in B, just in B. So here are the number of members just in A, not in this overlapping part. So there's also a small line here. The section contains those numbers who are not in either set. We also have many numbers who is not in either set here. Okay. So let's be more specific what you are trying to say here. Example, people at a party had a choice of cake or ice cream or both for dessert. Of 65 party group attendees, 18 select cake, 21 select ice cream, 16 take both cake and ice cream. So since we have plenty of time in this class, I think I'll just do something funny. Right now I'm creating a poll. What would you choose? Okay, so give me a minute. I'm creating a poll. Cake or ice? This is for our class. So I want to see the results in our class. Okay. So okay, everybody, you have a chance to do this poll. I created it already. Okay, great. So 15 of 15 have participated. So you see, can you guys see the result? You cannot? Huh, why I can see you cannot? Let me see how to. Okay, so share result. Okay, right now you should be able to see the results. Okay, so is it very different from your expectation? Can you guys see the result? Okay. Okay, so I was thinking that most people would choose both. Okay, however, an equal number choose ice cream and both. Okay, no worry. So let's go back to this example. So if you choose the cake, you are in this circle, okay? If you choose both, you are here. If you choose ice cream, you are in this circle. However, the way I designed the poll is that the number who choose cake are just here, which means all those people who choose cake but they didn't choose ice cream or didn't choose both. If you choose ice cream, it means you didn't choose cake. So your number is here. And this is the place where people choose both. Okay. So anyone has any question about this example? Okay, sounds easy. Let's just continue to our last question. This is literally our last question of today's class. Consider a study summarized in table 1.1. Table 1.1 is here, which is an example of two-way table. The study was designed to learn whether a pregnant mother's status as a smoker or non-smoker affects she delivers a low or normal birth weight baby. The table shows 4 numbers, which correspond to 4 possible combinations between birth weights and mother's smoking status. Okay, so you can see this on the lecture notes. A mother can be a smoker. So when she gives birth to a baby, the baby can be classified as low birth weight or normal birth weight. Intuitively, a smoker can give birth to lower birth weight. She can also give to normal birth weight. A non-smoker, she can also give to lower birth weight and also all normal birth weights. Those are all possibles. It is not definitive. If you are a smoker, you are going to give a low birth weight. If you are a non-smoker, you are going to a normal birth weight. This is not definitive. This is all depends on the chance. However, we have numbers recording how many people fall into this category, how many people fall into that category. So we are trying to discover if there is a relationship between smoker and low birth weight. Practice A. Make a list of summarizing 4 key facts about in the table. So the keyword is 4 key facts. So the first key fact I found is that, look at this number 18. There, in this study, there's 18 smoker mom give birth to low weight baby, right? This is what the first thing I found. You can just copy this line. What do you find on the second, 132? So if you look at this category, you see 132, they are normal birth weight, and they are also giving birth by smoker. Okay, so you can make a very similar sentence here, here, here. So 3 more sentences about 3 more facts here. So I'm just giving you an introduction. I'll give you a few minutes to do it on your own, since we have plenty of time in the rest of the class. Okay, then part B, drawing a Venn diagram. So after you make those 4 statements, we're coming back to drawing the Venn diagram. So let's say I give you 3 minutes to finish writing the 4 key facts and think about the Venn diagram. Then we come back together to draw the Venn diagram. Okay, 3 minutes. Feel free to ask me any question.
I have a question.
Yes.
Why do you think they decided not to do the same amount of smokers as non-smokers? Like I get that they have a distribution of 350, but to see if there's like a correlation between smoking and low birth, or like either or, wouldn't it make sense to have like an equal amount of both?
Okay. So thank you, Black, for asking this question. So the answer is that this is an observational study. Yeah. Observational study means you cannot manage how many people you observe. You just do observe, record everything you see. So let's say a professor in our university want to do a study about exactly on the same topic. He go to a hospital for a month. He check how many people, how many moms come in, give birth to normal weight and low weight. He or she does not have the rights to reject any cases, so that he does not have any control of how many members are there in each group. He just see it and record it, see it, record it, as long as she's working there collecting data. Hey, Blake, did I answer your question?
Yeah, it makes sense.
Yeah, great. So since this is a research about humans, I'm sorry, Frank, not Blake, apologize. Yeah, so if you are a social science major, if you are a medicine major, you will clearly see that there are two types of experiments. One is observational. You are just there, record whatever you see. You do not have the ability or the rights to control other people's behavior or change anything of your experience. You just record what you see. Just like this camera. He's not changing my face. He just recorded what this camera is seeing. However, there's another type which is called I believe it is called controlled experiments. So let's say you want to stress test. So how many miles can your tire in your vehicle can run? So imagine a factory trying to make different types of rubber with different materials and different quality. They want to test how many miles it's running. So this factory can choose, okay, I'm going to test on 100 tires. I'm going to test on 2,000 tires. I'm going to test those tires at a temperature, like say Fahrenheit, 100 degree Fahrenheit or 120 degree Fahrenheit, so that we can simulate the real road situation in Arizona. Or let's say we're going to test the tires at 0 degree Fahrenheit, so that we can simulate the road condition in Alaska. So those are controlled experiments. You, as an experimenter, you can pick up how many members you want to test and what kind of conditions of experiments. You can decide. Okay, so those are differences of two experiments. Okay. Okay, thank Frank very much for asking this question. Anyone has any question before we continue to the Venn diagram part? Or okay, let's just go back to the document camera. So I'm writing all the answers for the 4 key facts. I'm just copying each number to see what does this number mean. What does this number mean? Okay, so here we see a 186. That means 186 normal birth. 106 non-smoker mom. Give birth to, sorry for my handwriting, normal birth weight baby. Okay, that's it. Any question on this part? Here comes the funny part. How do you draw a Venn diagram? Okay, so first we draw a big rectangle to represent all moms. Okay, all moms. This is all moms. Only a subset of all moms are smokers. Okay, so this is smoker mom. However, only a subset of a smoker mom give birth to low weight baby. And only a subset of all moms give to a low birth weight baby. Okay, so you draw another circle to denote low weight baby. Okay, I'm running out of space. Just low weight, LW in short. So, okay, let's look at the overlapping part. Overlapping part means the smoker mom who give to low birth weight babies. So this circle means all the moms who give birth to low weight babies. Some of them are smokers, some of them are not. So there's overlapping between those moms who give to low weight and smoker mom. All the babies outside, all the moms outside of the circles, low weight give to normal weight. And they are also non-smoke, and give to normal weight babies. So that's why you have, that's how you get 4 categories. This category, this category, this category, and this category. Okay, so let's fill in all the numbers. First, this is the overlapping part. 18 smoker mom give birth to low weight babies. So the number here is 18. How many smoker mom who give to normal weight? Number here is 132. So 132 is here. Okay, 132 smoker mom give to normal weight baby. 14 non-smoker mom give birth to low weight baby. So here it is in this part. This part means non-smoker because it's outside the smoker circle, but also represent those people, those moms who give to low weight. So we have 14 here. 186, non-smoker, normal weight. So it's outside of those 2 circles. It means it should be right down here. Okay. Anyone has any question on the Venn diagram here? Any question? Okay, nobody has a question. Let's just continue to the next part. I, based on the Venn diagram, briefly summarize the results of the study. So let me give you an introduction, and I also give you 3 minutes to think about it. So this study want to find some relationship between mom, whether it is she's smoking, whether smoking causes lower birth weight. The researchers are trying to study if there is such a relationship. However, we find that this is not a definitive relationship. It's not if you smoke, you definitely will give to low weight babies. There's some kind of relationship, but not definitive. So how would you summarize the result of the study? I'll give you, let's say, 3 minutes to think about it. Then we come back together. Okay, feel free to think in any possible way. Okay, let's come back. So this is technically the last question of this lecture. So that's why I need a bit more opening discussion. So anyone has any thought? Feel free to speak out. Anyone has found anything unusual in the data? Okay. You guys are so quiet. No one want to voice only opinion?
It looks like it's slightly more likely your child will be underweight if you smoke during pregnancy.
Very good. Thank you. How would you say that in mathematics? What would make you think so in mathematics?
There were less smokers and more underweight children, and then there were more moms who were non-smokers and less underweight children.
Very good. You get a point. Thank you for Rochelle. Okay, so let's write the calculation exactly. If you do such a calculation, You see how many how many smokers we have? 18, 132, right? In this study, together we found smoker moms 18 plus 132, which give you 150 in total. Oops, I'm running out of space. Okay, so those 150 have total in 18 low birth weight. So the chance of each woman 18 low weight. So 18 over 150 smoker moms give to low weights. This, if you divide this should be 12%. Okay, in other words, 12% of the smoker moms give to low birth weight. So how about for those non-smoker? How many non-smoker do we have? Look at the table. We have 14 plus 186. So together we have 200. We have 200s. Among those 200 moms, how many give birth to low weight? 14. So 14 over 200 equal to 7%. Just do the math. 14 divided by 100. So this is a fraction. Both sides can divide by 2. So the bottom will be 100. The upper part give you 7. So 7%. Give to low birth weight. So I'm sorry, my writing is a little bit a mess here. So I hope everyone can understand. Only 7% of non-smoking mom give to lower birth weight. Baby. Okay, apologize for the mess writing. So do you see that if you are a smoker mom, you have significantly higher chance giving birth to a low weight baby? 12, 7, they are very different numbers, right? 12 is significantly higher than 7. Okay, so that's the point. If you are a smoker mom, you are more likely to give to low birth weight babies. Okay, that's the results of the study. That's it. Anyone has any question? Okay, perfect timing. So do not go. I am taking attendance. Do not go. Let me take screenshots to take attendance. Okay. Okay, great. I took a screenshot already. So stay here if you have any questions. Otherwise, feel free to go.
Bye.
Bye-bye.
Have a good night.
Good night. Good night and good night dinner. Hey, Elizabeth. Hey, Elizabeth.
Yes.
Do you want to talk with me for any question?
No, not really.
I'm sorry. Do you have any question for me?
I guess, could you make more than 2 circles for Venn diagrams? Like 4 circle Venn diagram?
Yes, you can. Yeah, that's a good question. We can definitely make more circles as long as we need. However, our class is a more introductory class, so that's 2 circles. That's our best, highest level
Okay.
of difficulty right now in the class. So if you look at the lecture notes, on the next page of the lecture notes, you will see we actually have more circles talking about blood types in the US population. But I'm not going to talk through this material. I will just leave this for your own interest. If you like it to read it, please read it. If you do not want to read it, that's fine. Okay, cool.
Have a good night.
Okay, great. Thank you for asking, Elizabeth. Have a good night.